Okay. Good morning again, class. Start tayo with filters. Balik ulit tayo sa filters. Last time, kunento ko sa inyo na may problema tayo sa mga normal nating filters. So ano ba yung normal na itsura ng filters natin? Okay, so yung itsura ng filters natin usually they look like this. Meron kang source/input. Tapos may resistor, may capacitor. Okay? Okay. So ang problema ulit dito, kapag nag-attach ka na ng other devices mo, nag-attach ka ng something here that would kung saan mo ikakabit yung everything else mo. Kuwari, di ba, ito ay isang yung voltage dito sa capacitor would be the low pass filter, di ba? Yung low pass filter. So pag pinifilter out niya yung pinifilter out niya high frequencies dito sa nilalagay mong input. Okay? Tapos sabihin natin gusto mong kunin yung signal na yun. Kakabit ka dito, di ba? Kakabit ka ng something else to receive that signal. However, in doing so, magbabago yung impedance ng total circuit mo. Okay, magbabago yung impedance ng total circuit mo and then maapektuhan yung voltage na nandito. Okay? Kasi magpa-parallel yung nito magpa-parallel yung impedances nito. So may problem. So kailangan natin gumamit ng mga filters using operational amplifiers. Okay, OpAmp. Okay. Let's recall yung recall natin yung voltage follower natin. So yung voltage follower, naalala niyo pa ba yung circuit? It's like this. Plus, minus, kakabit mo kung kanino man, let's say VI. Tapos itong negative, i-feedback mo. Naka-feedback siya doon sa output. Okay. So yung nito, yung equation nito, VO is equal to A. A yung natin, yung gain ng amplifier, which is a very large number. V plus minus V minus. But V plus is just VI. Tapos ito ay yung V minus mo, naka-feedback kasi. So nakakabit yung wire. Ibig sabihin, VO din ito. Tapos isolating VO, you have VO 1 plus A must be equal to A VI. And then VO must be equal to A all over A plus 1 VI. Okay, and then you do your approximation that A is very, very large. So this fraction here is just 1. Okay. So magka-cancel lang siya. So ito yung voltage follower equation natin. So anything na ikakabit mo sa plus mo would be directly sent as output. So in doing so, makakagawa tayo ng low pass filter. So let's recall the low pass filter. VI, whatever that is. And then may resistor ako, capacitor, and then ground. Sa low pass filter natin, nakakabit lagi yung voltage doon sa yung filtered signal would be on the capacitor. Okay. Pero natin, make sure natin na tama nga yun. So kung ito yung VO, let's call it V1. VF na lang. Okay. So VF is equal to yung mag-impedance model tayo tapos voltage divider lang to. So ZC. Ini-make sure lang natin na ito ay low pass filter. ZC plus ZR plus ZC. Okay, and then times yung input voltage. And this is just in terms of S and C. Okay, and then I multiply S over R, the numerator and the denominator. Para lang maging usual form siya. Okay, yung alam natin i-Bode plot. So this becomes 1 over RC all over S plus 1 over RC. Okay, and we know how to plot this in our Bode plot. Okay, so yung input-output relationship mo or in transfer function would become 1 over RC and then S plus 1 over RC. So hindi natatapos yung paggawa natin ng Bode plot, no? Hindi siya nagtatapos sa first exam. Uulitin natin siya for the second and the third. Okay. So ito, ipa-plot lang natin to. Yung numerator constant lang, so you know that that's a line. This is a line, 1 over RC. Tapos the other one, the denominator is may break frequency ka na 1 over RC. Tapos may height siya na 1 over RC. Okay, with a slope of 1. Then ito ima-minus mo dito. So yung height mo mag-zero out, quote unquote. Tapos ito ay bababa. So yung final na Bode plot nito would be something like this. So low pass filter. Something like this. Tapos ito ay 10 raised to 0. Okay? Okay. Anyway, ayan. So low pass filter nga siya. Okay. So to avoid the problem earlier, you just have to attach this to the positive end ng OpAmp mo. Yung positive input and your negative input would be a follower. And that's it. Okay? So in a more general representation, pwede nating palitan na yung VI. No? Kasi minsan nalilito kayo sa supply tsaka sa input. So this is the input VI. And then plus minus V. Okay? So anything na ipapasok mo dito, anything, if you filter out nito, filter out mo into a low pass filter. Okay. Next, high pass filter, gagamitin mo lang din yung shape nito. Ay, sorry. Ito pa rin yung circuit natin. Titingnan natin yung voltage across the resistor. Sir, paano po pag naunay yung OpAmp kaysa RC? Mag-iiba po ba yung effect? What do you mean OpAmp? Anong nauuna yung OpAmp? Sige, paki-explain kung ano yung ibig sabihin ng nauuna yung OpAmp kaysa RC. Sa OpAmp mo nadadaan yung VI sir bago po ma-filter. Wala namang problema. Ito ay building blocks. Para siyang Lego. No? Pwede mo ikabit to sa adder circuit. Pwede mo ikabit sa non-inverting circuit. So yung VI mo pwedeng manggaling sa somewhere na OpAmp din. Kunyari gusto mo ng inverting circuit. Kunyari meron kang VI that is VI that is low plus high frequency, tapos negative, tapos small. So kuwari meron kang input signal na ganito. Meron siyang low and high frequencies, meron siyang negative yung ano niya, value niya. Tapos maliit lang yung VI. So kuwari gusto mong Vout ay something that is low frequency na lang. Positive. Gusto mo positive. Then gusto mo large. Okay? So pwede mong gawin yung VI. Dadaan siya sa isang inverting OpAmp with large gain para maging large yung output niya. Okay? Maging large yung pagiging maliit niya magiging large dahil sa pagkakaroon nito ng large gain. Okay? Tapos i-invert mo siya kasi gusto mo maging positive siya. Okay? After that, yung unang OpAmp to, no? So unang OpAmp circuit to, papadaanin mo naman sa low pass filter. Okay? Tapos kukunin mo yung output. So sa exam nyo, hindi puro isang ganito. Cascade siya ng maraming OpAmp. May tatlo sigurong OpAmp, magkakadikit. So titingnan nyo lang kung sino yung ano ginagawa ng unang OpAmp. Inverting ba yan? Non-inverting? Adder circuit ba yan? And so on and so forth. So parang Lego tong OpAmp natin. I-attach yung yung mga building blocks mo para to obtain your desired output. Nagets ba? Yung voltage follower po na OpAmp laging meron. What do you mean na laging meron? What do you mean na laging meron na? Sige, explain mo yung question mo. Baka hindi ko lang naiintindihan. Okay? Okay. So kuwari dito sa after nitong low pass filter mo. Kailangan mo ba ulit maglagay ng follower dito? Hindi na kasi mukha na na to. Hindi na mag-exist dito yung problem mo. Kasi sabi ko nga, yung op-amp para siyang voltage supply. Okay, hindi siya naapektuhan kahit anong ilagay mo diyan ng malaking impedance or whatever. Okay? Okay. Sige, i-expound mo yung tanong mo para mas maintindihan natin. Okay. So, going back, sabi ko dito, yung high pass filter natin, you can use baliktarin lang natin, no? Resistor naman nasa kabila. For the high pass filter para mas maintindihan natin. Okay, VI, tawagin ulit natin VF ito. So, yung VF would be voltage divider ulit. Impedance model tayo. ZC plus ZR. And this is R over 1 over SC plus R. Okay? So, gawin natin na normal, ano siya, yung madaling form. So, mag-multiply ako ng S over R, I think, ulit. S over, joke, C over S pala. Multiply ako C over S. C over S. Baliktad. CS pala yung multiply ko. Sorry, nalito ako. CS. CS. Tapos ito ay R. 1 over CS din. Okay. Ito ay SRC. Ito ay 1 plus, ay mali pala yung multiply ko. But anyway, we'll get there. I-divide ko pa by everything by RC. S over R nga tama. S over R pala dapat yung una kami multiply. Anyway. I-divide ko by 1 over RC everything. Ginagawa ko to para ma-isolate lang yung S term. Para wala siyang factor. Para nakatugma siya sa process natin for the body plots. So this becomes S. This becomes S plus 1 over RC. Okay, and then yung plot nito would be for the numerator. Ito ay yung S natin would be this one. Tapos yung for the denominator, S plus 1 over RC. So ganun lang ulit. May 1 over RC na break frequency. Tapos yung height niya din would be 1 over RC. Tapos ganyan. Okay. Okay. Tapos ko-combine mo na siya. Sir, clarify lang po, bakit po may height yung plot po nung sa S? Okay, sige, para okay na. Okay. Adjustable naman itong mga bagay-bagay natin. Okay. Anyway, ayan, kasi ko-combine mo na lang sila. So ano itsura nito? Pag kinombine mo sila. So bago mag 1 over RC, ano yung mangyayari? Gaganon siya. Diba? Kasi yung slope ay 1 pa rin. Tapos, pagdating sa 1 over RC, 1 minus 1 yung slope. So, magpo-flatline siya. So, tama. Ito ay high-pass filter. So, pag kinabit mo dito, high-pass filter. Okay. So, gagawin mo na lang ay maglalagay ka ng voltage follower para magamit to. Okay, so this is your high-pass filter. Okay, so ito bumalik na yung tanong. Yung tanong ko po kanina ay if kailangan pa po na may voltage follower op-amp kapag meron na pong mga op-amps like inverting na nakakabit. No need ka na, ibig sabihin. Yung voltage follower, ginagamit mo lang siya kapag yung kakabitan mong voltage like here could change if you add another element. Okay. So yung element kasi dito pag kinabitan mo siya ng other elements, kinabitan mo siya ng other elements, magbabago yung impedance, magbabago yung break frequency and everything else. Kaya ka nag-voltage follower. Okay? Okay. Sige. Okay. Now, diniscuss tayo last time na active filters. May diniscuss tayo last time na active filters. I think this is it. Okay. So in this man, anong difference nito, no? Anong difference nito with the tawag dito? Yung dinidiscuss natin kanina. Okay? So ito ay pwede mo rin gawing low pass filter. Okay? Adjustable ito such that magiging low pass filter siya and so on. Okay? So anong difference ito? Ito ay mas general. Ito ay mas general. Ito hindi to intuitive. Hindi to intuitive. Tapos ang maganda lang dito, compact siya. Compact siya. Ibig sabihin hindi ka tawag dito, gumagamit ng follower. Medyo sayang kasi itong follower pag medyo sayang siya ng purpose. Okay? Kasi maganda sana, ideally, sa isang op-amp, marami ka nang magagawa. May invert mo na yung circuit, mabibigyan mo na siya ng amplifier, mabibigyan mo na siya ng gain, and so on and so forth. So ideally, maganda yung isang op-amp lang tapos marami nang nagagawa. Okay? Kasi sa isang op-amp, kailangan mo ng dalawang power supply. Okay? Kailangan mo ng isang power supply dito. Then another one here. Okay? Another one there. Okay. So kailangan mo, kada isang op-amp, kailangan mo ng dalawang power supply. Or kung meron ka nung nasa lab natin, no, LM358, dalawang op-amp lang yung magagawa niya in terms of two supplies. Two supplies is equal to 2 op-amps. So ideally you want lesser power supplies para mas madali buhay mo. Mas compact yung circuit. So syempre, di ba? Anong sense kung yung buong circuit yung laki ng bahay mo? That was the case for the first computers. Anyway, ayun, those are the two examples ng high pass and low pass filter natin. Now, ang problem dito, hindi naman siya problem per se, but this circuits, yung pagiging low pass nila and high pass ay yung quality factor niya, wala siyang quality factor. Hindi na-adjust yung quality factor nito. Okay? So kailan tayo nakapag-adjust ng quality factor? Kapag merong quadratic sa natin, sa body plots natin, doon ka may quality factor. So maganda sana kung meron tayong low pass and high pass filter that accounts for those quality factors. Okay, so meron tayong tinatawag na silent key filter. Okay, so pangalan tong dalawang to. Si silent at si key. Okay, and ito yung ito yung itsura niya. So this is a low pass filter. Okay. So medyo huwag kayong malula, no? Pag ganito, nakakita kayo ng ganito. Intindihin nyo muna yung nangyayari. So let's take a look at this circle. Ano ba to? Square ba to? Circle. Anyway, yung binibilugan ng dashed lines. Okay. So ano tong circuit na to? Kung papansinin niyo maigi, let's redraw this. Re-redraw ko lang, diba? Naalala niyo itong naalala niyo tong circuit na ganito? Ito ay non-inverting. Naalala niyo? Non-inverting circuit ito. So sa exam nyo, maraming mga ganitong bagay. Medyo magulo siya pero pattern recognition lang. Pattern recognition lang to. So ito raw ay V1. VO ito. Okay? Ayan. Balikan nga natin. Ayan ba talaga yan? Ito yun, di ba? Ito yun, di ba? So yan yun. Okay, and then yung final circuit nito would be VO. Tapos 1 plus R1 and 1 plus R1 over R2. Okay, ito 1 lang to. Tapos R1 over R2. So anything na ikakabit mo dun sa plus terminal ng OpAmp, i-output niya as like this. Okay, going back. Therefore, yung VO natin would simply be 1 plus R1 over R2, okay, V1 or kung ano man nakakabit dito. In our circuit, V1 daw siya, pinangalanan ng V1. Okay, so let's do that. V1 dapat din dito. Okay, and then for brevity lang, para hindi tayo mapapagod magsulat, let's call it G, V1. Okay. Okay. So sinulat ko lang tong factor dito as G para gain ng V1. Okay, now let's analyze this the other parts of your circuit. Tayo? KCL as usual. KCL at V1. So KCL at V1 would be V2 minus joke. Mag-assign muna tayo ng direction ng currents natin. So I want ito ay papasok tapos dito palabas. Again, walang current dito sa arm na to kasi walang pumapasok na current sa OpAmp mo. Okay, walang dumadaloy dito. Wala rin dumadaloy dito. So lagyan natin ng X para maintindihan natin na maalala natin walang nagdumadaloy diyan. Okay, KCL at V1, let's do this. So this is just V2 minus V1. Yung going in natin would be this part. That would be equal to doon sa going out. So nasa impedance model tayo. So V1 minus 0 over the impedance of the capacitor, which is just 1 over SC. And simplifying further, para mas madali ng buhay natin, SC V1. Okay? And this is easy to do, to simplify kasi V2 over R. And then, actually, multiply na ako ng R both sides para mas madali. Okay, so V2 minus V1, RSC, V1, and V2 must then be equal to 1 plus RC plus V1. Okay, so nilipat ko lang to sa kabila. No problem there. And then let's use the relationship for V1. So V1 is just V out over G. Lagay na natin to in terms of V out para mas maganda na siya. V out over G. Okay? Okay. V out over G. Now, mag-KCL ulit tayo. Kailangan ulit natin mag-KCL for this node sa V2 naman to make sense of the whole circuit. Then, wala na akong problem with regards to V1 kasi pwede ko siya isulat as V out. Wala na rin akong problem sa V2 kasi pwede ko siya isulat as V out. Okay, so masusulat mo siya in terms of yung lalabas na circuit dito in terms of V out and V in. So let's do that. KCL at V2. Let's assign the directions of the currents. Okay, to be consistent, no? Kailangan paganto rin dito. Kasi sa kanina, ganun na din ginawa mo. So maging consistent ka na lang para sigurado. Yan, ito yung going in ko. Tapos dalawa yung going out. So V2. Okay. Doing so, VI minus V2 over R. And this is V2 minus V1 over R again. Plus V2 minus VO. V2 minus VO. And then impedance ng capacitor, which is 1 over SC. Okay. And then linisin lang natin, tanggalin na natin yung mga denominator para mas madali. So mag-multiply ako R both sides and if you flip ko na to para maayos na yung buhay ko. VI minus V2. V2 minus V1 plus R SC V2 minus R SC VO. Okay? Pwede kong i-substitute yung mga alam ko for V2 and V1 para maging in terms of VO na yan. Okay? So I will be doing that after I simplify it para isang plug-in na lang. So iwan ko si input sa kaliwa, then yung mga output sa kanan. So VI na lang yung matitira sa kaliwa. Then you have 2 V2 minus plus muna. Pagtabihin ko na to. RSC V2. And then yung V1 ko, I could write that down as VO over G. I'm gonna do that now. And then ano yung last term? Minus RSCVO. Okay, may mali ako. So, dapat... Hindi, tama pa lang. Tama lang pala. Si V1 ay walang factor dito. So, yan lang siya. Okay, simplifying further. So, this is just 2 plus RSC V2 minus 1 over G plus SRC VO. Pinactor out ko lang yung VO. Pinactor out ko lang yung V2. Then I would have V2 as yung V2 natin ay ito. So I have 2 plus RSC times 1 plus RSC VO all over G. And then I have another here, kopyahin ko lang, plus SRC VO. Okay, all right. Distribute ko to. This is just 2 plus 3 RSC. Okay, so RSC plus RSC times 1 plus RSC times 2. So that's 3 RSC. And then S squared, R squared, C squared. Okay. And then that is all over G. Tapos, so factor out ko na rin yung VO. Okay? Pinactor out ko lang yung VO. Nothing difficult there. And then let's combine this. So ito ay magiging 2 plus 3 RSC plus S squared, R squared, C squared, all over G minus 1 over G. Tapos ito, multiply ko rin ng G. So, G RSC over G. Okay, ginawa ko yun para madali yung pag-manipulate sa numerator. Okay, so walang problema doon. And then, madali na lang yung everything. So, common denominator, G. So, 2 minus 1. So, 1 na lang yung matitira. Plus, for the RSC variable, this is, mali. Minus to. Minus dapat ito. Okay, so nag-distribute ng minus sign. Dapat minus to. Okay, so magiging factor nito would be 3 minus G or C times S. And then plus S squared, R squared, C squared, VO. Okay? Okay, so kunin natin yung transfer function. That would be VO over VI. Output over input. So mag-flip lang to. We have G. 1 plus 3 minus G. RC is plus R squared, C squared, S squared. And then, para lang mas maganda sa paningin natin, ipe-prepare lang natin siya for body plot. So I would be multiplying R squared, C squared. And then, ito ay last term would be S squared, R squared, C squared. Okay, so divide everything by, so numerator assist na lang yan. Hindi na siya ganyan. It's just a constant. Ito ay magiging G over R squared, C squared. Tapos sa denominator, divide ko lang to, di ba, by R squared, C squared. So S squared na lang. So ayan yung gusto natin, di ba? S squared na lang yung wala siyang kasamang factor. S squared. Tapos for the second term, for the S terms, that would be 3 minus G. And then S, tapos ito ay RC. Okay, so may isang kang RC dito, tapos dito RC squared. So isang RC na lang yung matitira sa denominator. And then lastly, yung constant term would be 1 over RC squared. Okay, ginawa ko lang ganito para mas maganda sa paningin natin. So ito na yung omega naught mo, di ba? Ito na yung omega naught mo. Ito na yung 2 alpha mo. Okay? Okay. So try natin i-plot to. Let's say we have G is equal to 2 and then RC is equal to 1. Then our transfer function H would become 2 RC ay itong numerator 2 over 1, 2 over 1 squared, so 2. Then yung denominator will become S squared. 3 minus 2, that's 1. Plus 3 minus 2 is equal to 1. Tapos yung RC mo ay 1 lang din, so S lang din to. And then, ito ay 1. Okay. So, evidently, makita mo na dito na ito ay isang low-pass filter. So, pa-plot mo siya. May comment. Random values lang yung G is equal to 2, RC is equal to 1. Random lang to. Ano lang, para lang mag-graph natin ng madali. Okay. Madali yung form mo. Okay? Para lang madali yung para lang mapakita natin ng madali na ito ay isang low-pass filter. Or at least it can be adjusted to a low-pass filter. Okay, let's do this. For the asymptotic plots, ito ay constant lang. Yung height niya is 10 raised to 0. Malapit doon. Tapos ito, for the second one, 10 raised to 0 din. Tapos, sorry. Okay, so yung sa x-axis nung sa mga sa x-axis ng mga quadratic, 'di ba? Kailangan mo yung square root nung constant term. Okay, since yung square root nito ay 1 lang din, so 10 raised to 0. Tapos yung height niya would be yung ito mismo. So ganun din. Kaya siya ganun. And then for quadratic, dalawa yung slope mo. 2 yung slope. Okay, 2. And then quality factor, never forget, huwag mo kakalimutan. May extra points yan, quality factor. Quality factor would be omega naught over 2 alpha. So 2 alpha is 1. Tama? Omega naught mo ay 1. Ang 2 alpha mo ay 1 din. So 1 yung quality factor mo, medyo magbabump siya ng konti. So yung resulting body plot mo would be subtracting these two functions, these two graphs. So, so it would look something like this. Okay. Tapos, ito ay 10 raised to 0. Okay? Okay, na-prove lang natin yung point natin na ito ay isang low-pass filter. Tapos, drawing natin yung body plot. Magbabump siya ng onte. Okay? Okay. So, with this type of filter, itong Sallen key, magagawa mong may quality factor yung quality factor yung filter mo. Sa kanina kasi walang quality factor to. So anong sense ng quality factor? Pwede kang magkaroon ng circuit time. Pwede kang magkaroon ng transfer function na ganito. Pwede kang magkaroon ng ganito. Oops, sorry. Okay. So, ibig sabihin nito, kung wari may specific, may specific kang frequency na gustong i-amplify, you can build the silent key filter para ma-produce tong peak dito. So tataasan mo lang quality factor, meron kang low pass, meron ka ring amplifier. Agad-agad. Okay, so again, we asked the question, no? What's the difference with this and yung active filter natin last time? Itong active filter natin. So the difference is, mas maraming nagagawa to. Mas maraming nagagawa. Kasi meron siyang non-inverting. Parang 2-in-1 siya. Okay, 2-in-1 ito. So ma-achieve mo rin ma-achieve mo rin sa active filters na normal na active filters yung ganitong transfer function, yung binigay natin na transfer function, ma-achieve mo rin doon sa kabila. Ang maganda lang dito, sabi ko nga, pag nag-design ng mga circuit, gusto natin maging compact para mas maliit yung device mo. Okay. Para mas dali buhay mo. Okay. So going back, try natin isa pang itsura or type ng silent key filter. High pass naman. Ang mangyayari lang, ganito. So meron tayong input VI, tapos capacitor naman parehas. Okay, and then, wait, saan nakakabit yung isa? Okay. So, R, C, C. Okay, and then, maganda dito sa silent key filter, pwede kong gawin lang ito na follower. Okay, follower lang to. Diba? Ang ganda niya, ang compact niya. Pwede mong gawin in non-inverting, tsaka pwede mo lagyan ng gain o di kaya walang gain. Okay, so gawin ko lang muna walang gain para madali buhay natin. So VO is equal to, lagay tayo ng, dito? Same variables, V1. Immediately, alam natin na VO is equal to V1. Kung ano ikakabit mo sa VO, ganun din mapupunta sa V1. And then, similarly, KCL ka agad kay V1. So, mag-drawing tayo ng current directions, tapos i-X-mark natin yung walang dadaluyan na wires. Okay, so V2 minus V1, KCL lang. Tapos, yung impedance niya would be 1 over SC. Must be equal to V1 minus 0 divided by R. So, simplifying this, actually, SC R V2 minus SC R V1 must be equal to V1. Okay, so mabilis lang ginawa ko. Nag-multiply ako both sides ng R. Inayos ko lang yung fraction dito. And then, you'll have V2 as something like this. V2 over SRC. So, V1. And then V1 can be written in terms of the output. So VO lang din siya. One plus SRC, VO. Okay? Okay. And then you do the other KCL. So sa example kayo, paano KCL? KCL is life. KCL at V2. Dito naman, assign tayo ng circuit current directions. Yan na. So dalawa yung outgoing, isa yung incoming. Okay, incoming would be VI minus V2 over 1 over SC. It must be equal to V2 minus VO over R plus V2 minus V1 over 1 over SC. And then similar process, I would just multiply R both sides. CVI minus RSC V2 must be equal to V2 minus VO plus RSC V2 minus RSC V1. Okay, and then isolate things. RSC VI be equal to, pagtatabi-tabihin kayo ng mga V2 ha. V2 plus RSC V2 and then plus RSC, another RSC V2 minus RSC V1 minus VO and then factor this guy out. 1 plus 2 RC is, ang gulo ko nung hindi ako consistent dun sa ordering ng RSC. Anyway. Okay, yung V1 is just VO. So we have minus VO times 1 plus RCS. Okay, and then V2 is just, ano yung nakuha natin form? Ito. 1 plus SRC. Ito ay 1 plus 2 SRC. Sorry. Hindi ko matiis. SRC denominator. Okay, and then minus, ay yung VO na wala. Okay, so may VO yung sa V2. Minus VO again, 1 plus SRC. Final na yan, SRC na lang. And then multiply ko lang para maging quadratic. Ito ay 1 times 1 plus 3 SRC, tama ba? And then plus 2 S squared RC, R squared C squared, SRC, tapos minus. Gawin ko tong SRC minus SRC. Ito yung 1. Tapos minus SRC squared SRC para lang common denominator all multiplied by VO. So may pinactor out natin VO. Okay, so constant ay wala. 1 plus SRC, 3 SRC minus SRC, that would be 2 SRC. Tapos sa numerator, for the third term in the numerator, 2s squared r squared c squared minus src squared, that would be squared r squared c squared. Okay. And then all over src. Okay, VO. Then you can have your ano yung V kabila. And have your input-output relationship. So VO over VI. This would be S squared, C squared. And then ito ay denominator mo would become S squared, R squared, C squared plus 2 SRC plus 1 and then this would result to sige, divide ko everything by R squared and C squared para maging S squared. Ito ay denominator S squared plus 2 S plus 1 C squared okay. Bakit naging squared yung numerator? Meron pang RSC dito. Okay, meron pang RSC dito. Okay? Kuha. So ito ay high pass filter. Kung titignan nyo maigi, meron tayong S squared. So dalawang S lang yan. Dalawang S lang. So pababa siya. Pababa. Ito ay 10 raised to 0. Ito ay 2. Okay, so dalawang S plus 0 lang to, no? Dalawang S plus 0 lang. Tapos, the other one, sa denominator, it would look like something ganyan, di ba? Okay? Ay, pataas pala to. Ba't pababa? Ano ba yun? Sorry. Pataas to. Ba't pababa? Sorry. Nalito lang ako. Okay, ito ay S squared. So, dalawang S lang yan. So, pataas. Taka ako ba't mali yung ano. Anyway, ayan. Pag pinag-combine mo itong dalawang to, you'd end up with something like this. So, tataas muna siya. And then, pagdating sa break frequency, magto 2 minus 2. So, gaganon siya. Okay? And then, ito ay may quality factor. So, kunyari, pag ganito siya dito, pag minus mo na siya dito, makakapili ka ulit ng magandang quality factor para ma-increase mo yung output at this frequency. Okay, so that is your silent key filters. Okay, okay, okay. So any questions? Any questions? Relevant po ba sa body plot yung exact Y value? Yes, relevant siya. Hindi ko lang ginagawa ngayon kasi tamad ako. Okay, gets yun na yan. Dapat gets yun na. Pero hindi naman ako nagbibigay ng weird na, ano? Hindi ako magbibigay ng weird numbers for the, type. Okay. Kailan ginagamit yung silent key tsaka normal high pass, low pass filters? Okay, so kung kailangan mo lang ng general na low pass or high pass filter, you can use this. It's a simple one. Okay? It's a simple one for your needs. Gagamit ka ng silent key filter kapag gusto mo na ma-adjust yung quality factor. Okay? And then for pagiging compact. Okay. Pwede kang mas maganda to for compactness. Pwede kang kasi mag-inverting, di ba? Pwede mo rin siya i-follower lang. Ayan. I mean, non-inverting pencil. Okay? Pwede ba ang na-inverting yung nakakabit sa silent key? So dito sa kabila, tingnan natin na ba shape ng inverting circuit. Hindi. Sa inverting kasi kailangan yung input mo nandun sa Okay. Nandito sa mismong negative. Okay. Kaya special tong silent key filter kasi ginagamit niya efficiently yung plus and minus terminals nung OpAmp. So sa other examples natin last time, pansin nyo, si plus nakakabit lang lagi sa ground. Okay. For the simplicity of the mathematics, ng algebra, para mas madali siya. So, kaya siya may sariling name, no? Kasi na-design nila to such that efficient yung paggamit mo ng OpAmp. Okay? So, yung exam nyo would be on November 12, Saturday. Okay? Kasi sabi nila, meron daw kayong, yung iba sa inyo merong NMAT sa weekend ng 5 and 6. Okay? And then, syempre, next lab meeting, wala tayo, November 2 yun. And then, November 3, merong ganap na yung summit ba yun? Student summit, something. Okay, so November 3, wala daw klase. Suspended. From 8 a.m. to 4 p.m. ata yun. So November 3, wala tayong klase. Ang next na meeting natin would be November 7 for the lecture and November 9 for the lab. Yes, magkakaroon kayo ng at least 2 prob set to help you solve things for your exam. Tapos, yung problem set number 3, magbibigay ako ng bonus sa mga magpapasa ng November 9. November 9. Okay, maganda na nagawa nyo na yung prob set 3 kasi it would help you for your exam kasi lalo na sa mga nagkagulo-gulo yung buhay sa first exam. Okay? Basta, may tanong dito. Basta ba silent key filter, magiging low pass or high pass na siya? Depende actually. Itong dalawa lang na to, specific siya for a low pass filter. Itong dalawang resistors dito. Tapos yung mga branches ay capacitor. Ito ay low pass. And then may specific combination na magpapalit yung ano dito. Magpapalit yung RNC dito to produce other filters. Okay. But the idea stays the same. You phase CL at those points. You obtain your input-output relationship. Okay. And then, i-ano ko na pala ngayon, i-share ko na yung plano natin sa final project para you can start working on it kung gusto nyo lang. Okay. Ganun pa rin po ba duration ng exam? No, mag-force ko na kayo mag 3-hour exam para wala na maghihingi na extension. Okay, 3-hour exam tayo. So on November 12, you would be having your exam from 1 to 4 p.m. Yung room ay to be determined pa kasi mag-schedule pa and everything. So 3-hour exam, tapos almost that amount of work. Baka magtatlong items tayo. Dalawang items would have 4 sub-items. Tapos yung last question, yung additional question would have 2 sub-items. So baka may essay. Dahil meron na tayong mga diniscuss na bagay na kailangan lang ng words. Okay, so let's discuss the final project. Let's have it here. Final project. Your final project would be creating a blood glucose monitor. Non-invasive blood glucose monitor. Okay? Okay. So, paano yung grading nito? Yung grading nito. So, 20% would be yung theoretical work. Theoretical. 20% would be the actual circuit. Okay, so yung theoretical, consult lang kayo online. Okay, will this work? So, sure na may 20% kayo. Basta mag-consult kayo and i-approve ko yung theoretically, that would work. Then you build your actual circuit, that would be 20%. Not necessarily working. I mean, dapat gumagana na siya. Pero not necessarily accurate. And then another 5% for the LCD. And another 5% for instruction manual. / yung infographic. Okay. Okay. Etong LCD, this is to be provided. Can be done online. So, sulat natin. Can be done online. And then actual circuit, lab session. Lab session LCD to be provided. To be provided. Meron tayo nito. Medyo mahal kasi siya, may 100. Pero bumili na ako for all the class. Pero babalik nyo siya, no? Hiram lang siya. Hiram lang siya. And then yung instruction manual or infographic, ito ay, ayun, instruction siya. Instructions kung paano gagamitin yung device niyo. So non-invasive glucose monitor, Ayan. Feel ko maraming questions. Pero mag-explain muna ako. Okay, so yung LCD, this wouldn't be a problem kasi sa syllabus nyo, kung titignan yung syllabus nyo, meron tayong lab activity regarding LCD. Okay, LCD. So, meron tayong lab activity to be nagagawin para mapagana natin yung LCD using the Arduino. Okay. And then, okay. Kung mapapansin nyo sa syllabus, after ng design experiment number 2, actually isang activity na lang. That would be LCD module. Tapos yung isa lab demo naman. So ako yung gagawa ng isang heart rate sensor. Papakita ko sa inyo paano gumagana. So on and so forth. Okay. So yung other lab meetings, that would be reserved para magamit natin yung time to build your final project. Okay, so gagamitin yung, pwede kayong mag-request ng mga material sa lab para mas madali yung pag-work on nyo. Okay, and then syempre, to test your non-invasive blood glucose monitor, bumili ako ng ng isang yung kinukuha na ng dugo para may gold standard tayo. Okay, so libre to. Magte-test yung isa sa inyo, sa mga members, no? Isa sa mga per group, may isang itetest ng blood glucose nila. Pero ito ay invasive. So kukuha lang kayo ng dugo. Yung piprick lang naman. Konti lang naman, hindi naman masakit. Okay. So with that, meron kayong theoretical data to benchmark your blood glucose monitor. Okay, so diniscuss ko na to actually kung paano gumagana yung mga bagay na ganito. Kung maalala nyo sa sensors and transducers. Okay. Okay. And then ito ay gumagamit ng sige, bibigay ko na rin. Ito ay gumagamit ng optical yung yung means niya ng measurement. Okay, so yung reflectance yung reflectance nung glucose nyo sa dugo would vary with the increasing amount. So mas malaki yung nire-reflect nung mas maraming sukal sa dugo, syempre. So pwede meron akong actually yung materials for the diode photodiode na gagamitin niyo dito. So emitter and receiver. So pwede niyo gamitin yun. But I'm not limiting you to use optical means. Baka mamaya may makita kayong research na gumagamit ng other means, tapos available available yung component sa somewhere in the internet, tapos makukuha nyo naman agad. So why not kung tataas yung accuracy mo? So this is just 50%, tama? 20, that's 40, then another 10, 50%. So the bulk of your other 50% would be coming from the accuracy. So 25% person 1. And another 25% for person 2. Okay, so may dalawang tao na magte-test ng device nyo. Okay? So somewhere in December, sa last days of the December, kailan yung ganap natin for probably December 14. December 14 ayun yung testing natin for your final project. Okay, so paano yung grading nitong yung accuracy nyo? So kapag within notes ko, within 2%, that corresponds to 25 points. Tapos within 4%, that's 20. And then 6, 15, within 6% yung error. And then percent error to, no? 8 would be 10. And then within 10%, so that's 5. Pag nag-exceed ka ng 10, 0 ka na for that person. Okay? So same goes with person 2. Now, magbibigay ako ng bonuses. May 10% tayo for portability. Okay? Ibig sabihin ng portability, pwedeng mabuhat yung device nyo. Okay. So kasi pwedeng for this base na 100%, pwede siya nakakabit sa laptop. Okay, nakakabit sa kung saan man. So hindi siya mabubuhat, hindi siya malilipat-lipat. Pwede siyang gumagamit ng power supply sa lab. Okay. But if you can make it portable, you'll be given around 10%. So depende pa kung gaano ka portable yung portable. Baka mamaya portable yung sinlaki ng laptop, ganun lang din. And hindi mahirap din. Okay, so you would not get full points. Then another one would be, may extra points pa dito, 5% would be ergonomics. So ibig sabihin na ergonomics, madaling gamitin for person. Okay? Kunyari, meron kayong light and sound feedback para malaman ng tao na okay, tapos na yung measurement or may nag-error sa measurement and so on and so forth. Okay, kuwari nag-red yung hindi ko po nabasa yung hindi nabasa ng device yung nangyayari. Nag-green yung device. Sabihin, I could read your blood sugar. And then kuwari may sound to indicate that the measurement is done. Okay, mga ganung bagay. Okay? So, all in all, I guess you'll have... Actually, pwede natin taasan to ergonomics. Sige, taasan ko to. Kasi kayo sa ergonomics, kayo na yung bibili nung kung ano mong gusto nyo bilhin. Ito 10% ko na to. So, 120% yung total. Bawing-bawi yung mga bababang other lab experiments. Okay? So any questions? Any questions? Ayan. Okay. Sir, ask ko lang po if parang bahala po ba kami kung ano po yung kukuhanan naming measurement. Basta po hindi blood. Oo. Basta non-invasive siya. Ibig sabihin, hindi kayo kumukuha ng something inside the person. Okay. Hindi kayo nagte-take out ng fluids, ganyan. Ng pawis. Okay? So, pero yung based nito, bibigay ko na yung kung gusto nyo, yung na siya, photodiode emitter tsaka receiver. Okay? So, yung mag-emit ka ng light towards the infrared light towards the surface of the skin, tapos i-reflect ng skin yon and the other things inside. Yung mga lab sessions natin would be checking your circuits. Okay? Checking your circuits. Tapos yung isa pang lab experiment would be benchmarking the accuracy of your circuit. So, itetest ko kayo nito or at least magtetest kayo sarili nyo. Ipapatest ko kayo na sarili nyo to have your own accuracy. Okay? So, isang lab activity na lang after design experiment 2. And then the rest would be reserved for making your final project. Okay? So maraming meetings yun. So November 9 would be your last activity for bago mag-design experiment 2. And yung design experiment 2 would be 16. Tapos you have 23. 23. So one meeting for the LCD module. December 7 would be, ay, isang meeting na lang pala. No? November 30 ay holiday, tama, di ba? Tama ba? Hindi ko sure. Anyway, we can have one meeting for that. Ay. Sir, hindi na po ba kami babalik sa campus sa January? Oo, hindi na. Tatapusin na natin by December para pahinga na. Ay, sorry, namatay yung ano ko. Okay? Hopefully hindi na kayo babalik by December. So, dapat tapos na tayo sa exam by December. So, anything else? Anything else? Sa day ba ng actual testing, isang beses lang magte-test? Isang beses lang. Okay, isang beses lang for the 2 persons. So yung sa paggawa nyo ng circuit, doon na kayo magte-test, no? Okay? Medyo mahal yung strips nung blood glucose monitor. So kaya isang testing lang yung gagawin ko sa inyong lahat. Pero kung maka-secure ako ng more strips na mura, baka sige, payag akong dalawa. Dalawa per group. Okay, so any more questions? Okay, kung wala na or kung meron man, you just have to send it to me by email or Canvas. So lagpas na tayo sa time, so go na tayo. Thank you for attending the class.